All right, chapter 4, discrete probability distribution. Let's do some basic definitions before we get into this. Let me tell you what a random variable. Random means, guys, random. Just you don't intend, just to get a specific thing. It's done randomly, so you wouldn't know what the outcome is going to be. Represents a numerical value associated with each outcome of a probability distribution. It's usually denoted by X. Let me give you some examples of the random variable. Number of sales calls a salesperson make in one day. This is not fixed or predetermined, guys. So this is random. The number of calls a person can make could be as low as 0, as high as whatever, 100, 200 calls, etc. Hours spent on sales calls in one day. This is also an example of a random variable because the hours change. It could be that the person made no calls at all, so it would be 0. Could be an hour, 1 hour, 0.5, 2.5 hours, etc. Can you guys give me some more examples of random variables? I have a C, and I'm going to put a D here. So say something for a variable that turns out to be random. It changes. It's not fixed. What do you guys think? What do you think of the number of students present today in my class? Students present. This is random. It could be as low as 0. It could be as high as the total number of students in my class. I hope it will never be 0, so it will be just me. Let's do another variable X. Any ideas, guys? What do you suggest for a variable? Any ideas? Let's say number of hours you study a day. Could be as low as 0, as high as 24 hours a day, but no one does 24 hours of study. So this is a random variable. So anything you come up with, guys, that it changes, it usually turns out to be a random variable. Now, let me tell you what a discrete random variable, and this is the highlight of our chapter. It's about discrete probability distribution. If you can see the title, guys, it's discrete. Has a finite or countable number of possible outcomes. So the outcomes of a discrete random variable has to be whole numbers, 0, 1, 2, 3, 4, 5, 6. You cannot get a decimal or a fraction or anything. It has to be a whole number. For example, X is a number of sales calls a salesperson make in one day. You know, the number of calls can't be a fraction or decimal. It's either 0 call or 1 call or 2 calls or 3 calls or 4 calls. So that's an example of discrete. Can someone give me another example of a discrete variable? So make sure it's countable. You can count it on your fingers. What would you say for X?
The number of children you have?
Yes, number of children in a family. Cannot have 1.5 child, so that is discrete. And the number of children, guys, could be as low as 0, 0 children, 1 child, 2 children, 3 children, 4 children, 5, 6, 7. So that's countable. Exactly. Let's go to continuous now. Continuous means not countable. It cannot be a whole number. Impossible for it to be a whole number. Has an uncountable number of possible outcomes. So when you say countable, guys, means you can grab your fingers and start counting on it, using them. But if it is uncountable, you couldn't do that. It's usually represented by an interval on the number line. Any ideas, guys? What kind of things that are not countable? They're measurable, but not countable. I'm waiting, see if you have some ideas. What would you think? Any thoughts of something that variable that you cannot count? 0, 1, 2, 3, 4, 5, etc. No? What do you think of this? Weight of a person. The weight, guys, doesn't have to be a whole number. If someone's weight is 120 pounds, that doesn't mean that the next heavier person is going to be 121. It could be 120.45. It could be a decimal. So anything, guys, that you have to use a tool, measuring tool to measure, it's not countable. It turns out to be continuous. So that's an example of a continuous random variable. Height of a person. That's probably going to surprise you when I put this. Do you think your age is countable? Well, I said it's not. I put it as a continuous. Age, if someone is 17, it doesn't mean that the next time this person is going to grow a little bit older is going to be 18. It could be 17 in few days, in few minutes, in few seconds, in fractions of a seconds. So this is not countable. If it was countable, that means that if a person is 17, the next one is going to be 18. Well, you know, this is not true. You could find someone whose age is between 17 and 18. So in this case, if you can do that, that's not countable. So it will have to be continuous. Okay, let's do some more examples. Determine whether the random variable X is discrete or continuous. X is the number of Fortune 500 companies that lost money in the previous years. What do you think, guys? Continuous or discrete? Yeah, amount of sugar is continuous, yes. What do you think of the number of Fortune? Can you count them? The one that lost money? Yes, out of 500, it could be 0 companies who lost money, or 1 or 2 or 3 or 4 or 5. You can't have 2.5 companies. That's not possible. So that's discrete. What about the volume of gas in a 21-gallon tank?
Continuous.
Definitely. It doesn't mean, guys, if you consume gas, if the car consumes gas if it has 21 gallon and then consume a little bit of gas, then it went down to 20. It could have been a fraction of a gallon. It could be few ounces, few fluid ounces. This cannot be determined exactly. Once you cannot know something for sure, exact measurement, then it is continuous. Maybe this is something probably will surprise you. You know, the papers that we use are 8.5 by 11-inch paper, the standard paper size. But is the width or is the length exactly 11 inches? Well, actually, it's not 11 inches. How do you know? It could have been 10.9999, but your ruler will not be able to pick up, you know, that little bit of a tolerance of a decimal in there. So because this is a measurement that is continuous. So anything you use a tool to measure, remember, is continuous. Now we're going to tell you what a discrete probability distribution is. Okay, I'm gonna, before I explain, I give you the definition, I'm just gonna start with an example. And then from the example, I'm gonna generate the definition that I already listed there. Okay, let's look at this example and then we'll go over this. An industrial psychologist administered a personality inventory test for passive-aggressive traits for 150 employees. Individuals were given a score from 1 to 5, where 1 was extremely passive and 5 extremely aggressive. A score of 3 indicate neither trait, nor passive nor aggressive. Construct a probability distribution for the random variable X, then graph it. Okay, we're gonna show you. We have a distribution table, guys, a frequency distribution table. There were 24 employees who got score 1, the quiet ones. 33 got a score of 2, 42 got a score of 3, 30 got a score of 4, and 21 were very aggressive. They got a score of 5. Okay, here's my question to you guys. If you have this table, if I ask you, if we select one employee at random, what's the probability that this employee received a score of 1? Which is a probability of 1. Can someone help me? It will be. You've done that. This is the empirical rule and probability. 24, I agree. 24 divided by 150. If we select one employee at random, what's the probability that this employee received a score of 2? You guys agree that it is 33? Look at the 33 over 150. And I'm gonna keep going. Probability of 3. It's gonna be 42 divided by 150. And probability of 4, guys, it's gonna be 30 divided by 150. And probability of 5 is going to be 21 divided by 150. Okay, we're gonna, so actually probabilities, guys, are relative frequencies. You take the frequency of the event and divide it by total frequencies. We call them relative frequencies in chapter 2. In chapter 4 now we call them probabilities. So I'm gonna show you how to construct this probability distribution. You put an X here and you put P of X. You just copy and paste this line right here. 1, 2, 3, 4, 5. And over here, guys, instead of putting the frequencies, you put the relative frequencies. 24 divided by 150 will be 0.16. And this will be 0.22. And 42 divided by 150, it will be what, 28%. 30 divided by 150, guys, is 20%. And finally, 21 divided by 150 is 14%. What we did now is called a probability distribution. Now, how do you ensure that what we got is called a probability distribution? You have to make sure that each probability is between 0 and 1. Can we check this one, guys? Is this is this a go here? Yes, each probability is 1. Does anyone know if I add all those probabilities, what should they add up to? Any ideas? 1, exactly. If you add them, you should get 1. This is the second condition of the probability distribution. Because I did construct it to be such a probability distribution, so it's gonna turn out to be 1 for sure. If you add them up, guys, you will get 1. So if I give you a table, guys, on the next test, and I ask you, can you check if this is a probability distribution or not? Look, you check for 2 things. You make sure that each probability is between 0 and 1 inclusive, and the sum of all probabilities is 1. If one condition fails, guys, you don't have a probability distribution. You're gonna see that in a second. But if both conditions apply, check, then you do have a probability distribution. Now, the next question here, determine if the following distribution is a probability distribution. Well, guys, this is a copy of the table that I did there, but I put it in a horizontal way. So each probability is between 0 and 1. You can see that's between 0 and 1, between 0 and 1, between 0 and 1, 0, 1, 0, 1. And you guys, if you add the probabilities, you're definitely gonna get 1. So the answer is yes. Let me show you a couple more examples from the book and tell me if what we have is a probability distribution or not. So just 1 second. In example 4 on page 193, if number 1 is a probability distribution or not. First of all, ask your question. Is each probability between 0 and 1? They look between 0 and 1, but you need to add them, guys. If you add them, what do you get? So you got 0.28 plus 0.21, that's 49. And 0.43, that's 92%, 0.92. So I got 1.07. So what does this say, guys? That this is not a probability distribution because I got a sum more than 1. It can't be less than 1. It cannot be more than 1. What do you think of the next one, guys? Example 2. I need a quick answer for this. That's very easy to tell that this is not a probability distribution. How do I know? We're expecting some feedback. Okay, negative, yes. And Julia says 5/4 is more than 1. I agree. You need one excuse, guys. You don't even need both. A student says we have a negative probability. That is true. It's impossible, guys. It's impossible to have a negative probability. That does not happen. And it's impossible to have a probability that goes above 1. So you have 2 violations. It's not a probability distribution. All right, so this is the example of probability distribution. Let's continue from there. Just wanted you to have a feel of what probability distribution is. How do you find the mean of a probability distribution? So any distribution has a mean. Even probability distribution, guys, have a mean. And I'm going to show you how to find the mean of the probability distribution. It's this formula. I will show you how to use this formula, and I'll show you how to do it on the calculator. This formula, it says to find the mean, it's the sum of x px, which means that each value of x is multiplied by its corresponding probability, and the products are, what word would you put here, guys, to interpret the summation notation? Are added. And let me demonstrate this to you guys. It's very easy way to find the mean. Look, if you are given on the next test, and you will probably, definitely, you will have a question finding the mean. You will be given the probability distribution be asked to find the mean. So you start sum of x px, which is 1 times 0.16 plus 2 times 0.22. Can someone do the math for us as I do this? I want the session to be as much interactive as possible, guys. So I appreciate it if you participate with me. I think the mean is going to be around 2 to 4 because this is most of the probabilities are. You got 22%, 28%, 20%. All the concentration is close to 2 to 4. So it wouldn't be anywhere near 1 or near 5. It will be anywhere between 2 and 4. Do we have an answer? Yes, no? And it does make sense for the mean to be 2.94. Look, guys, this is the concentration here. You got about 30, 50, 72% of the data around between 2 and 4. So it turned out to be right in the middle. So this is how you find the mean. Now I'm going to show you how to do this using your calculator without doing this calculation. Watch. You grab your calculator. The first thing, if you want the calculator to assist you, you need to provide the calculator with the data. So you need to provide the calculator with the x values and the probability values. And also tell the calculator that 1 matches with 0.16 and 2 matches with 0.22 and 3 matches with 0.28 and so on and so forth. So how do you do that? You go to stat, edit, and you enter the values in L1 and L2. I've already done that. So L1 for the X values and L2 for the probability values. And now, guys, you go to stat, calc, one variable statistic, and pause here. Okay. If you have the newer calculator, it's going to ask you your X values in L1, and then it's going to ask you for frequency. You have to put L2. We usually leave it blank. We did leave it blank in chapter 2. But now, since we have X values and we have their frequencies or their probabilities, we have to put L2. Now, how do you do it on this screen? You just press the second, guys, and number 1, and then you put a comma right here. Watch, guys. This is the comma. And then you put second and number 2 and enter. Did you see the 2.94, guys, on top of the screen? That's the mean. And not only it gives you the mean, it gives you the standard deviation of the probability distribution, which is 1.27. You can see it right here on the screen, 1.27. So I'll write it down. Now standard deviation, you know how to do it. You don't need to use the formula, but there is a formula for the standard deviation, but I don't require that you do it. You just can use the calculator. And sigma square, which is the variance, will be 1.27 square, guys. And if I square this number, it would be 1.61. Any questions on how to find the mean of the probability distribution, guys? You could do it by hand. It is fast, not difficult at all. But if you guys want to use the calculator, you just put this in L1 and this in L2, and then you run one variable statistic, which I already provided all the details on how to use the calculator. So X bar would be the mean, and sigma X would be the standard deviation. And this is how you write X bar right here. All right. Any questions so far? So what we have done so far, we learned what a random variable is. We learned what to differentiate between discrete and continuous random variables. We learned what a probability distribution is. It means that every value has to be between 0 and 1, and the probabilities add up to 1. And we learned how to find the mean by hand and by using the calculator, and the standard deviation using the calculator. Now, expected value of a discrete random variable. It's called E of X, and you guys, you can see it is the mean. So the mean is called the expected value of the random variable. And I'm going to show you an interesting example. What does the expected value mean in statistics? For example, if I want to invest in a stock and I ask someone to tell me what is the expected value of return, if they give me a negative number, probably I should not invest. Means it is very likely that I'm going to end up losing. But I'll explain that in more details using this example for the expected value. So remember, guys, the expected value is the same as the mean. But what does it mean? We're going to give you a nice visual of what the expected value is through this example. There is a raffle. It has 1,500 tickets, and 4 of the tickets are winning tickets. One is worth $500 prize, $250, $150, $75. So out of 1,500 tickets, they're going to pick 4 winning tickets. To buy a ticket, you pay $2. What is the expected value of your gain? So we want to know, if you gain money, how much you're going to gain on average. So on average, are you going to gain or lose? If you lose, how much? If you gain, how much? This is what the expected value is. In order for me, guys, to find the mean, I need to have X values and P of X, and then use the formula. So my first question to you is, you buy a ticket. You spend $2. Is your $2 marked as gain or loss? What do you guys think? Is it a gain or a loss?
Loss.
It's a loss because you pay $2. Once you pay $2, you don't have this money anymore. And how would you express a number that is a loss in mathematics? It would be wrong to put this.
So -2?
-2, exactly. Otherwise, it's a gain. If you put a +2, then it means I gain $2. No, I don't gain $2 when I play a game. I lose the money right away. Now, can someone tell me what's the probability of losing this $2 now? I'll help you. I put 1,500 at the bottom. There are 1,500 tickets. What is the numerator? The numerator are the favorable outcomes. How many tickets, guys, are losing tickets out of the 1,500? Just one? No. How many tickets are there are only 4 tickets that have prizes, but the rest of them, 1496, yes. Your chance of losing, guys, the $2 is 1496 over 1,500. Very good chance that you lose. But let's go to the other scenario now. If you really gain money, so the first -2 is a loss. So I should have put here gain or loss here, but I put gain. So it's a gain of -2 means a loss of $2. If you win the first prize, which is 500, okay, how much money do you gain? Can someone answer this question?
500.
No, you don't gain 500. You gain 498 because they're going to get your $2 back. So your actual gain is 498. And if you guys find this a little bit hard to comprehend, think of this. If you have a business and you sell goods, if you sell an item for $100, does it mean that you gained $100? No. You already have expenses, you have the cost of the item.
I actually like the case, whatever you said, the first one. Yeah.
So you guys, gain is the actual profit. You only make 498. And what is the chance of making this 498? There is only one winning ticket that has the grand prize, 1 over 1,500. Okay, I think, guys, you know what this number is going to be. Next one is not going to be 250. It's going to be 248. And your gain is 1 over 1,500. Probability is 1 over 1,500. And then if you win 150, you actually gained 148 because you need your $2 back. And then if you win 75, actually you gain 73 because you need your $2 back. So now I have the table, guys. I can find the expected value or the mean, which is like this. -2 times 1496. If a student can help us do the math here, plus 498 times 1 over 1,500 plus 248 times 1 over 1,500 plus 148 times 1 over 1,500 plus 73 times 1 over 1,500. If you do this with the calculator, guys, this is why I suggest you do. You do -2 times 1496, and for negative is right here. This is the sign for negative, guys, right here. Then you add 498 times 1 plus 248 plus 148 plus 73, and then divide by 1,500. You don't have to keep dividing by 1,500 every time. You just do it at the very end. And your final answer, guys, is going to be -1.35. What does it mean? For someone who doesn't know statistics, explain what the expected value is. Any ideas, guys? What does a -1.30 expected value of -1.35 mean? I'll start it. You are expected to what? To gain or lose?
Lose money.
Lose $1.35 for each. Who can complete this? You buy one ticket. So for each ticket you buy, you are expected to lose how much? $1.35. Why it didn't say you lose the entire $2? Because there are chances that you would win, but they're very low chances. But guys, the expected value tells us this is a losing game. On average, you're going to be losing. You're not going to be gaining. So you are expected to lose. For your information, all the gambling machines in Las Vegas are programmed to give you a negative expected value. Because if the expected value is a positive, let's say this answer turned out 1.35, then you'll always gain money. Every time you're playing, you're going to gain money. So nobody will do anything. We'll just go and play games and make money. So it's going to be negative. It won't even be a zero, because an expected value of zero means 50-50 chance of gaining or losing. So it's always a negative value. Anywhere you go in Las Vegas, any game you play, it's a negative expected value. And you can see here what a negative means. Any questions? We're done with section 4.1. We're gonna go to section 4.2 now. That's pretty much it. I'd like you to know. Now, can you do the expected value using the calculator? Yes. You put the X values in L1, you put the PX values in L2, and you just run, find the mean, just like we did before. It is the mean, actually. What is a binomial probability distribution? We say that a probability distribution like this one is binomial if it meets the following condition. If the experiments are repeated for a fixed number of times. So you don't do an experiment forever. You keep doing it and doing it and doing it and doing it, like run a computer program and then it keeps doing simulations forever. No, it has to be done for a fixed number of times. And when you run an experiment, there are two possible outcomes, either success or a failure. Let me give you an example. Roll a die 10 times. You have success if you get a 5, and you fail if you don't get a 5. What's the probability of success on a single 6-sided die? Probability of success is 1/6. What's the probability of failure?
5/6.
5/6, yes. So it's the same. Does this change from one roll to another? It doesn't. And you're doing it 10 times. This is an example of a binomial experiment. You see here, it says the probability of success is the same for each trial, does not change. If it doesn't change, then you have what we call a binomial experiment. Now we use some symbols for this. N is the number of trials, how many times you do an action. P is called the probability of success. And Q, guys, they call it in statistics the probability of failure. And for your information, probability of success plus probability of failure should add up to 1 always. So as you saw, 1/6 is the probability of success when rolling a die and getting a 5. 5/6 is the failure. Well, if you add 1/6 plus 5/6, you will get 1 for sure. And X, guys, is the number of successes. Let me ask you a question about X. If I roll a die 10 times, I will have success if I get the number 5 face up. What are the possible values of success? How many times could I be successful? Successful means I'm going to get a 5 face up. If you roll a die 10 times, what are the possible values of success, possible values of X? Roll a die 10 times. I'm going to write it down here. Success if you get a 5. Okay, possible values of X. Can you help me list them, guys? What do you think? X is how many times 5 is going to show up, face up, when you do it 10 times. Any input here? Is it possible that you roll a die? No, I don't want the probabilities. Is it possible that you roll a die 10 times and you don't get any 5s at all? Is this a possibility? Yes
Yes.
or no? Yes. So X could be as low as 0. Is it possible that you roll a die 10 times and 5 shows up only once? Yeah. Or maybe twice, or maybe 3 times, or maybe 4 times, or maybe 10 times, but the probability is very low, guys. Try it at home. Roll a die 10 times. Are you going to see 5, 5, 5, 5 every time? I mean, it could happen, but the chance is very low, but that's a possibility. I'm not saying that it is happening for sure, but these are the possible values of X. For your information, X is a number of successes. It will always be as low as 0 and as high as the number of trials. And since we're doing it for 10, you can see why I put a 10 here. So these are the possible values of X. Okay, guys, let's read this and tell me if you think the experiment is binomial or not. Remember, the condition of the binomial. You do the experiment fixed number of times. There are two probabilities. One is the probability of success and one is failure. And the probability of success does not change from one trial to another. Then you have a binomial experiment. Let's read this. A certain surgical procedure has an 85% chance of success. So he gives me P. A doctor performs the surgery on 8 patients. So you know what 8 stands for, guys. It's N, so fixed number of trials. So that's condition number 1 is met. The random variable represents the number of successful surgeries. Is this a binomial experiment, guys? Yes or no? Yes. And let me tell you why. Fixed number of trials. And I'll tell you what they are. 8. 2. Probability of success is 0.85. Can a student tell me what's the probability of failure? You 15%, very good. And 3, probability of success does not change from one patient to another. Because they say it's 85% for everybody. Here you go. That's a binomial experiment. Let's look at number 2, guys. That could be a yes or no as well. A jar contains 5 red marbles, 9 blue, and 6 greens. That's the jar. You randomly select 3 marbles from the jar. Without replacement, the random variable represents the number of red marbles. So N is 3, guys. He says 3. You just do it 3 times. So that's fixed. Fixed number of trials. Is this a binomial experiment, guys? If yes, tell me why. And if no, tell me why.
No,
Why not?
because you don't have the same chances of success because it's not getting replaced.
Exactly. Very good points. And let me demonstrate that to you guys. You pick a marble at first. What's the probability of getting a red to begin with for the first marble? Let's do it. I have 5 reds out of the grand total, which is 20. Okay. If I do the second marble and I get the same probability of red, that means I have a binomial experiment. If it changes, that's a violation. Let's see, watch guys for the second marble. Remember, it's without replacement, so I'm not working out of 20 anymore. My denominator is changed into 19, and it's 4 out of 19 now because we already picked one. So 4 out of 19 is not the same as 5 over 20, guys. You can try on your calculator. And since the probability of success getting a red is changing, then you don't have a binomial experiment. Because probability of success changes from one trial to another. All right. So this is what binomial experiment. The last part of section 4.2, guys, is to show you how to find the probabilities when you have a binomial experiment. And we're going to do this example. Please pay attention to it. And that should cover, along with the next example, everything you need to know in this chapter. Microfracture knee surgery has 75% chance of success. Who can tell me what 75% represent? It's NPQ. Q is the probability of failure. P. Very good. With degenerative knees, the surgery is performed on 3 patients. Can someone tell me what 3 represent? Yes. Can be Q. Q's probability of failure, so N, I agree. Very good, guys. That's what we need. And can you tell me what Q is? He doesn't give it to you, but you can find it. Q is the probability of failure. 0.25. Very good. Find the probability of the surgery being successful on exactly 2 patients. So, probability of success on exactly 2 patients. Does anyone know how to do that using chapter 3 knowledge? You could. It's a little bit long, but any ideas, guys, and how to find the probability that 2 surgeries out of 3 are successful? Any ideas? Okay, let me do this, guys. Okay, here's the first patient. Second patient. And third. Okay, patient 1, patient 2, patient 3. Okay. He didn't tell us which ones of the 3 have successful surgery. It could be any 2, but not 3 together. So it could have been that this patient and that patient had successful surgery, but the third one didn't. Or it could be the second and the third had successful surgery, but the first one didn't. Or it could be the first and the third had successful surgery, but the second one didn't. So there is or. So if I want to do it using chapter 3 knowledge, guys, this is how I could have done that. But there is a formula. You don't have to worry about it. Let's say patient 1 had success. It's 0.75. Patient 2 had success, 0.75, but patient 3 failed, so 0.25. You multiply those 3. Now let's say patient 1 had success, patient 2 had failure, 25%, and then patient 3 must be success because we need 2 out of 3, and then you multiply them. There's one more scenario, guys. Let's say patient 1 had a failure, and then patient 2 success, and then patient 2 success. You do this, it's either this scenario or that, and or in mathematics means addition for probability. So you just multiply those 1, 2, 3 numbers, and then you add them. Plus, and then plus, and you get the answer. But that's a lot of work. This is not how we're gonna do binomial probability. So I'm gonna show you how to use the formula. I'm going to show you how the formula works by hand, but then we'll go to the calculator and apply the formula in a second. anytime he asks you for exactly X successes, which is right here, guys. You see, exactly 2, exactly X. You apply this formula, and let me explain this formula. This formula says, n choose X, which you learned in section 3.4. Take the probability of success and raise to the X power, and take the probability of failure and raise it to the n minus X power. N is 3 in our case, and X is 2. So n is 3, X is 2, P is 0.75, and Q is 0.25. So watch and see how the formula works, guys. So it says, n choose X, 3 choose X, P is 0.75, raised to the power of X, which is 2. And then failure is 0.25, and raised to the power of n minus X. N is 3 minus 2, which is 1. Okay, let me show you how to do this. We're not using the calculator yet. When I say calculator, it's a program in the calculator. We're just doing here calculations. So 3, math, choose 2. What did I get? 3, and then multiply by 0.75 raised to the second power, and then times 0.25. Enter. That's the answer, 0.422. Okay, change the pencil. .422, and if I add those guys, they should be 0.422. All right. Ready now to see how the calculator works with this. So anytime, guys, he asks you to find the probability of exactly a number, you will do the following. And see the magic of the calculator now. You go to second and distribute. And you scroll down until you see what we call a binomial Pdf. So binomial Pdf is reserved for exactly. Anytime the question is exactly, you use this formula, binomial Pdf. You press enter. Okay, if students have the newer calculator, it's asking you what are the number of trials, what is the probability of success, and what is the value of X. We need to enter them here. Number of trials, guys, is what? 3, comma. Probability of success is 0.75, comma. And then surgery, successful surgery is asking for 2 only. And then press enter. I should match exactly with the number that I got earlier, which is 0.422. So using TI-84. Press second, variables, Binomial Pdf, and then enter the value of n, p, and then x. N is 3 in our case, p is 0.75, and x is 2. And this is how you use your calculator to find the probability of x equals 2. How do I do this, guys, if he says what's the probability that none of the surgeries are successful? Any ideas? What changes in the formula? It's the same formula, guys. But if he says none of the surgeries are successful, exactly x equals 0. I got a student saying x equals 0. Yes, you put 3, you put 0.75, and you put 0. Let's see what's the likelihood that the doctor will perform 3 surgeries and none of them is successful. That's bad news for the doctor, but let's check. Second variable. But you're gonna see, guys, the probability is very low. N is 3, comma, 0.75, comma, 0. Enter. There's only 1.6%, something like that would happen. It's a very, very low probability, guys. That 0 surgery, the doctor performed 3 surgeries in one day and none of them is successful. That chance is 1.5%. What is the probability that the doctor will perform the surgery and all surgeries are successful? Exactly 3 of them are successful. Let's check. So you change X to 3. Second variable. Enter. N doesn't change, guys. P never changes. These the first 2 values do not change and you don't play with them. Just leave them the same. And 3, you get 42. Same as 2, so 42%. Okay, that's how we use the formula. Let me go to the next exercise. It's a good review of what we're doing now. All right. So I'm right here using TI-84. I do encourage the use of the calculator in this chapter and other chapters, you will see. The results of a survey indicates that 67% of US adults consider air conditioning a necessity. Who can tell me what 67% represents here? You can say it, type it. Which letter? P, very good. If you randomly select 10 adults, what's the 10, guys? Yes, 10 is N. All right. Okay. What is the probability that exactly 7 of them consider air conditioning a necessity? So he wants a probability of X equals 7. And you guys, you know that exactly means binomial Pdf. You have to put the value of N, the value of P, and then the X value. So N is 10. This is 0.67, I'm sorry. And then 7. Okay, guys, I'm gonna give you the chance to calculate this and share the answer with me. Sounds familiar. Okay, let's do the math. It's very important, guys, that you can use the calculator here. Okay, so we're gonna go to PDF. Only for exactly, this is reserved for PDF. So I have 10, comma, 0.67, comma, 7, close, and you are correct, 0.261. What about if I say what's the probability that all of them consider air conditioning a necessity? What would you change in this problem, guys? You change only one thing. What would that be? If I say what's the probability that all of them consider air conditioning a necessity? All of them, that means X is, yes, change X to 10, exactly. Yeah, and then you do the math on the calculator. What about if I say what's the probability that none of them consider air conditioning a necessity? So you change X to what? To 0. Yes, yes. All right, very good. Part B. What is the probability that at most 7 adults consider air conditioning a necessity? Okay. At most, guys, means less than or equal to. and you write it like this with this sign. So he wants, guys, probability of x less than or equal to 7. Less than or equal to 7, it doesn't mean 7, guys. It means 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. There are no decimals between 6 and 7. That's why it's all whole numbers. We're doing only discrete case. And these are people, guys, adults. You cannot have 6.5 adults or 3.5 adults. So it's all discrete. Does anyone have an idea how to do this one? Probably using what we did. We're using the tool that we did in part A. But actually, they're going to be a shortcut. But I'm just curious to see if you guys, you were asked to do this one right now, how would you find it? What's the probability of x less than or equal to 7? Any ideas? Curious to see how you'll be thinking about this. Okay. So in order to do probability of x less than or equal to 7, it means the probability of x is 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. Luckily, there is a program on the calculator that can take care of at most only, guys. So anytime you have a question about at most, the program on the calculator is designed to answer this question. And here is the program. You can see it's not the PDF. The PDF is only for exactly. I want you to walk out of today's lesson knowing the difference between the two formulas. This one is for exactly, but this one, guys, CDF, this is a cumulative density function. This is designed for at most. So if you're taking notes, guys, take a note that binomial CDF should be used with at most. And here's how you do it. You press enter. You put n, which is 10. You put a comma, 0.67, and you put 7. Definitely, you're not going to get the answer as part A because this is cumulative. It's going to do 7, 6, 5, 4, 3, 2, 1, and 0 for you. And here's the answer, 693. So it will be binomial CDF. And I link them together like this. N is 10, 0.67, and then 7, which is 0.693. Any questions, guys? If you were asked on the test to find the probability that at most 5, you just put CDF and then you do it with 5. At most 8, you just change 7 to 8 and do it. What do you think at most 10, guys? You should know the answer without doing any work because the sample is 10. What's the probability that at most 10 of them will say air conditioning is a necessity? That means 10 or 9 or 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. You don't need to do any work to figure out the answer. What do you think the answer is? 100%. Yes, 1. The answer is 1. Okay, part C. What is the probability that more than 7 adults consider air conditioning a necessity? You write more than 7 like this, guys. It's more than 7. This is where we need a little bit of algebra. And more than 7 means 8 or 9 or 10. Any idea how am I gonna do this? Please remember, guys, there are two formulas. One is for exactly and one for at most, no other formulas. So for C, you just have to tweak things around, you know, and figure it out. Any ideas? How would you do probability of x greater than 7? What's the chance that you will say more than 7 adults will say air conditioning is a necessity? Any ideas? Okay, look guys, what you can do. You only have 2 tools and you gotta have managed to use them. There is one way to do it. Since it's 8 or 9 or 10, you can do exact PDF on 8, a PDF on 9, a PDF on 10, and then add them up, but it's a lot of work. So let me tell you what the student was saying. We need 8, 9, and 10. But what is it that we don't need? We don't need the 7, the 6, the 5, the 4, the 3, the 2, the 1, the 0. These we don't need. So that's what we need. You agree with me that that's what the question is about. But this is what we don't need. Watch here. And do you guys agree with me that this is at most 7? From 7 and down, it's at most 7. And we already have done it. We did it in part B. So since we already did this in part B, but this is not the one that we want the remaining stuff. The remaining part will be 1 minus the answer in part B. So that will be 1 minus probability of X less than or equal to 7. And since you already did it in part B, you just get the answer and you're done. So a way around when you do more, guys, when he asks you to do more, then you cannot do it directly. What you would do, you know, just a binomial PDF on the remaining stuff, and then you subtract the answer from 1. So for example, if he says more than 5 means 6, 7, 8, 9, and 10. So what you do a binomial CDF on 5 and below, and then you subtract the answer from 1, and so on and so forth. So this is how you can work out with the more than. Any questions? Here, okay, I'm just gonna change this less than 7. Of them consider air conditioning a necessity. And here's how you write this one. What are the numbers that are less than 7, guys? Can you share them with me?
0, 1, 2, 3, 4, 5, 6, 7.
Would you want to include the 7?
Oh, no, 6.
Okay,
I forgot.
I agree. So it's 6 and below. So you guys, if he asks you to do less than 7, you can use the binomial CDF to do it. But watch. I said the binomial CDF is reserved only for at most, and I'm not going to change my wording here. It's always at most. But look, you put the N, you put the P, and you guess what I'm going to put here. If a number is less than 7, would you agree with me, guys? It's at most 6. Yes or no? Remember, we're doing discrete. There are no decimals. So probability of X less than 7, guys, it means X is at most 6. There is no 6.1 or 6.2 or 6.3. These are people. So you just put 6 and you apply this. Okay, let's do it. And there you go. Second variables, binomial CDF. And you get 10, comma, 0.67, comma, 6. And you get 0.432. So guys, in part D, if he asks you what's the probability that less than 5 consider air condition a necessity, you do at most 4. If he asks you less than 3, you do at most 2. If he asks you less than 9, you do at most 8, and then use the binomial CDF formula to do it. So it's always one less. What I will do tomorrow when we review 4 before we begin 5, I'll do a summary of what to do, you know, just for if he asks you to do equal, less than or equal, greater than, less than, etc. So we'll do this. The last part, guys, which is the easiest part, if you are asked to find the mean of the binomial distribution and the variance of the binomial distribution, Remember the mean when we start section 4.1, it was sum of x, px, but it was probability distribution, now binomial. Well, the mean is n times p, very easy formula. It's not built into a program on the calculator because it's very easy. And the standard deviation, guys, is square root of npq. So let me show you how to find the mean here. The mean is n times p. I never had a test and students failed this part because it's very easy to do it. So it's 10 times 0.67, which is 6.7. And sigma, which is the standard deviation, here's the formula. And we'll be done after this, guys. Square root, n is 10, 0.67. Now I need the students to help me with the q. What is q here? You need a q for the formula.
Can you pull up the paper a little bit?
Yes. Is that good?
Yeah, thank you.
Okay, so what is q, guys? Q is the probability of failure. So if P is 0.67, Q is 0.33, I got 0.33, and let's do the math. All right, so I'll have you do it as I do it as well, and make sure that we match. So 10 times 0.67 times 0.33, and don't forget to do the square root. You do the hat here and put 0.5 for square root. And I got 1.49. And if he asks you for the variance, guys, I'll add it here, which is sigma square. It's 2.21. But he didn't, he just says standard deviation. So the standard deviation of the binomial distribution is square root of MPQ. There's no program on the calculator that will do this because it's very basic. Well, actually, guys, I do have time. We still have time to give you the shortcuts. So I'm going to write them down before I let you go, and we'll meet again tomorrow. If you are asked to do a probability of X equals A, that's exactly, here's what you do. It's Binomial Pdf. Let's say we have an N and P. So you put the N, the P, and then the A, guys. Now, if you are asked to find a probability of X less than or equal to A, which you guys agree with me, this is at most. You do binomial CDF and then N, P, A. If you are asked to do probability of X less than A, less than 7, guys, that's part D. Who can tell me what the shortcut here? What do I put in there? Less than 7, we did a binomial CDF on 6. So if I'm doing, just some formulas for students and ways to figure this out, what should I put here?
A minus 1.
A minus 1, excellent. Now, if you are asked, guys, to do probability, just like in C, more than A, we did 1 minus binomial CDF N P A. Last one, which we haven't done yet. Tomorrow when I review, I'll do something with that. At least A. At least, guys, means greater than or equal to A. And it will be 1 minus binomial CDF N P and then A minus 1. This is everything that you need to know about working with binomial distribution. So this is the equal at most. This is, guys, means less than. This is a greater than or more. And this is at least. Any questions? I think with this one, guys, we wrap up chapter 4. There's going to be a very short assignment. Let me show you the assignment of chapter 4 and a practice, which I'm going to send it to you just right now after I hang up with you.